All right, thank you. So I'm going to try to show you the basics of deploying an IDP in the 20 minutes I have. So this is going to be a quick one. Bear with me. So IDP, I'm calling this steal this IDP, and the reason is because I hope that's what you do with it. I want you to steal it and make it your own, or if you don't, perhaps contribute to it or make a bunch of GitHub issues and yell at us about the things you want changed. All of this is welcome, but the point is that you can do that because it's open source. For the purpose of accessibility, when I say IDP, I mean Internal Developer Platform. If you hear me say any other acronyms that I forget to spell out, please say something in the chat and let me know. So now, why would you want to steal an IDP? Well, it's something like 67% of platform teams are failing at this initiative. And then to make it worse, the analysts are saying that 80% of organizations are going to adopt this. If that's true, we are in for a lot of toil. But whose toil exactly? If you are a developer, you're actually in a great spot for the most part because it's your toil that everyone is tripping over each other to reduce. But at an error rate of 67%, are we really reducing it or are we just sort of moving it from here and placing it over there? And there are many reasons why this could be happening. But one that I think is frequently overlooked is that although we are very good at being dry, as in don't repeat yourself, we're not always so good at being drrr, which is short for don't reinvent the wheel. And we do this all the time. We love reinventing wheels. I love reinventing wheels. It's a lot of fun. But we have to be honest about the times where that comes back to bite just a little, like perhaps at scale. So, what this is not a full fledged IDP. It's a proposal on how to take a more drawer approach to building IDPs. So, you can take the practice that we all believe in of golden path templates and think of this as one giant golden path template for building the IDP itself. The app platform, which is the thing I'm going to show you, 100% open source. So let's say 95% CNCF projects. The 5% of custom sauce is also open source. It's just there to glue things together and smooth out the process. And that makes it cloud agnostic. And if you don't believe that cloud agnosticism is important, it is my belief that you should. But more importantly, dog fooding. This came from, I was managing a product team and we were looking at this as something perfect to use ourselves internally. The challenge we ran into is that the core development of it is focused more on a UI experience, and we're a team that likes to do everything as code. So we've kind of had to experiment with that and make that this project. And what I'm going to show you is one iteration of that internal project that I have put over into a public repo, sanitized and whatnot. And I will share that link at the end of this. And I encourage you to follow along with it because as the real project matures and takes shape, I will be porting over more of it. But also keep in mind that it is still heavily prototyping, so lots of things are subject to change. But with that said, the tech stack, we are running on Kubernetes. We are using Pulumi for infrastructure as code and for secrets management. We picked Pulumi because of its flexibility that we have in these unforeseen twists and turns we might run into, and because I really just appreciate that it lets me be a programmer about it, and I don't have to refine my YAML engineering skills or deal with the rigidity of HCL. And then the app platform is the thing I'm showing, is really just a big old Helm chart that installs a bunch of subcharts and then just ties it all together. If you hear me say LKE, that is Linode Kubernetes Engine. That's just the Kubernetes flavor that I'm using. APL would be a shorthand for app platform. And OBJ, I'm talking about object storage. So what we did here was we narrowed down that nebula of CNCF projects to just this opinionated set that covers all the fundamental pillars of a production-ready environment. So from observability to security and source control, developer tooling, and so on. So if you're going to look at this from that kind of golden path template for the whole thing approach, and with the understanding that this is a Helm chart as the mechanism for deployment, what I'm showing you here first is the start of my values.yaml file. And if you are familiar with Helm, the values file being where you provide the overrides of the manifest that it's deploying. So in this sense, if we're golden path templating the deployment, this is a big deal because this is where we do so much of that design and customization, and we are painting and fully furnishing our home before we ever walk in the front door. If you recall that last slide with all the CNCF projects, I showed you all those apps that we narrowed this down to, but not all of those are actually flipped on in the default install, only a small amount of them, which is the way it should be. You should always start small with just what you need and add on from there. In this case, I know that this team needs a little bit more than that. So this is where I can not only flip on more of those, but also define some parameters for the other ones. So I have turned on monitoring for this team. With Argo CD, that's one that's there by default, and it is doing most of the heavy lifting, and knowing that I am giving more or throwing more at it, rather, I give it some more resource. I tuned the ingress controller with some annotations for a static load balancer that we already have DNS pointing to, as well as turning on Harbor for a self-hosted container registry, Knative functions, RabbitMQ, because that is something I'm aware of this team using quite a bit, and then, of course, the rest of the observability stack. For a key management service, this comes configured with GitOps out the box. So you could use Azure or AWS or HashiCorp services. We are using Age as the provider because it is lightweight and the most vendor agnostic. So this is simply encrypting the values of our secrets in our config files before they are written to the Git repository. I'm going to skip past the OBJ part because this is really just defining the prefix for the buckets to get created. But next, for platform backups, this is a retention policy and schedule and the prefix for where you find them in the OBJ buckets. For the most critical databases that are the beating hearts of this platform, being Git, Harbor, and Keycloak. And then this last block here, the team config, this is the one I'm going to pause the most on because, again, if we're thinking about this in terms of a golden path template for the whole thing, really what is an IDP? It's a team's experience. You don't build these for one developer. In fact, you don't build this for one team of developers. So this team's experience that you want to replicate, this is where we're giving that so much shape. And we can do everything from defining the teams and the initial users and their passwords, to assigning them admins, to attaching additional Git repos and container images, to having services and deployments running in their team space, namespace, Kubernetes cluster before they ever log in. So much we can do with this. I'm not going to show all of that right now. This is much more simplified, but that's just to give you an idea of the power that we have just in this one file. So this team, I've named this team Develop. They have some self-service capabilities where they can create new services in the cluster, and they can also download their RBAC kube config. They have monitoring turned on for their own stuff, as well as some basic network policies. And we'll start off with the resource quota of 50 pods and 10 service load balancers. Now, if we fire this off, the Pulumi part of it, I don't have time to get into, but this is using the Pulumi automation API. So we're firing from a custom Go file here that I have prototyped right now to deploy in 4 stages. This first stage is just provisioning some of the cloud resources. So that's going to be the object storage buckets and the Kubernetes cluster. And I'm even creating a separate object storage key that is scoped just for this deployment. So we can see those resources starting to create here. And then if we look over at the Cloud Console, we should see there are the object storage buckets, as well as the Kubernetes cluster is provisioning, looking good. Now, if we look back over at where Pulumi is at, it looks like it just finished the second stage of this, which is deploying the static load balancer and setting up some of our DNS. So again, looking back at the Cloud Console, we see that the CCM there just created that load balancer that is pointing to our Kubernetes cluster. And just as much, we should see the domain created for the DNS zone. And as this goes along, we'll see it populate with the subdomains from all the various CNCF apps. Now, if we head back over to Pulumi, it's now on stage 3 of 4, which is just a wait for DNS propagation stage for the auth and keycloak subdomains, before heading to the final stage, which would be the one that deploys the Helm chart of the app platform. Now, once this is done, the job is over as far as Pulumi is concerned. This is all that I've asked it to do. I could make it hang out for longer to see the deployment end of the chart, but then we're subject to timeouts and other things. Pulumi's job is done here. If I actually want to see the APL job, the chart deploying, which can take 5 to 10 minutes to do so, you can just follow that APL job in the default namespace and watch it all unfold in real time. Once it finishes, you'll see this little message of the day here that give you these kubectl commands that you can copy and paste to get the login for the initial platform admin user, the default login that is. And it is okay that this password is given to us in plain text, because Keycloak is configured to force you to update that password on the first login, which is what we are doing right now. Pop that in, hit submit, and this is your platform. From a UI perspective, this looks like a cloud provider's console, but it is not. This is your platform running in your Kubernetes cluster to do whatever you want with. So let's just explore some of that real quickly. If I go to settings, I'll click on object storage. If I select Linode here, this could have been already connected, but I wanted to demonstrate the GitOps aspect of it, where I click that little button there, and we have this pop-out on the side that tells us to hold on. And it is a Tecton pipeline with a commit hash. So if we take a look at that, we come to a self-hosted Git instance that we log in through OpenID, through Keycloak. And then if we look at this values repo here, we can see that commit with the diff that is connecting our object storage. So again, that's just to show you GitOps, out the box, pre-configured, no further steps necessary. And every single user interaction, everything that would do a write of any sorts is going to trigger that. So next I'm going to show you the apps. You remember I defined which ones we were going to turn on, as well as there's some that are there by default, but this is what I did in that values.yaml file. There was one that I forgot or after the fact want to flip on once I'm logged in here. I can simply just click this on button. It's a user action. It's something that we're writing. So we have another pipeline that writes to our Git repo. And now we have added Thanos. So the next thing I want to show you is this Teams view. If I were to log in as a member of that develop team, this is what I would see. And you can see there's already Grafana dashboards just for this team, just for their own stuff. And there's also, if we want to look at the apps, there's a separate set of default apps just assigned for this team that we can also configure via that values YAML file or through the UI, through the admin, once this is set up. But you'll also notice that those other options on the side there have changed. So we have this thing called a catalog, which is very exciting because we love catalogs for platform engineering. And I'll come back to that in just a sec. But if you look at these other items down here, this is the feature stack for developing and operating cloud-native applications. You can see we can add more code repositories and custom container images. We can have team-spaced, namespaced, sealed secrets. Workloads just in this namespace, which is going to translate to deployments in Kubernetes speak. Network policies. This team can add services and so on. So this is that developer experience that we want, that they can just log in and have the tool sets they need to just do the things we want them to do and build this cool cloud-native applications. And with monitoring, alerting for their own stuff. And they are given a great amount of flexibility in what they can do within their own environment. Now back to this catalog thing I mentioned earlier. We're going to look at this from another team view, from the admin team. The reason we like catalogs is because they have us build out this environment for our teams. And what's a catalog if it's not extensible? So this one, easily extensible by simply adding the URL to the chart.yaml file that we want to add. In this case, I know that this team likes to use Apache Cassandra. So we'll just go ahead and grab that chart YAML URI, paste that in. It goes and fetches all the details for us. Make sure that box is checked because we do want the team to have access to this. And then you click the submit button. And we have Apache Cassandra. So this is all great and all, but this is all the UI experience so far. And that just isn't really how our team likes to do things. We like to do everything as code. And for two reasons, two good reasons. One, because it's more fun. And two, because code scales, right? We're not going to manually do this through the UI for every team that's geo-dispersed all over the place. So just to quickly demo how we would go about that in the code way, we can clone this charts repo. And then let's say I want to add nats. So I will clone that repo as well. Looking good. And then it is really as simple as just copying it over and pushing it up. And now if we go back to the Git instance and refresh, we see the commit there with everything it grabbed from the upstream nats repo. And if I refresh the catalog, let there be nats. And then the last thing I want to show you here, and this just in terms of portability, is that if you want to see how we did any of this, whether it's just because you're curious or you do want to reinvent the wheel because it's fun, you can download, hear the values, and look at every single piece of this in every single chart. And with that said, I'm a couple minutes over time, but I will hang out for a bit in the Q&A, and also feel free to find me on LinkedIn.
That's awesome, Billy. Thank you.